Okay, College Algebra, Chapter 4 practice test, continuing with number 14. In problem 14, you're asked to calculate the natural log of e to the 6th over 11. Now, let's see, we're going to expand wherever possible using the properties, no calculator values. They want exact values, so let's look at how that's done. First of all, this is a quotient, so the way that you're going to take apart the quotient is ln of the top minus ln of the bottom. Okay, so that would be that part. Then you're going to see if any other properties apply once you have deconstructed it to this point. It does in the first term because the base here would be e. Inverse property applies here. The e's take each other out with the log. So this expression, this first term in the expression is equal to 6 minus ln of 11. So when they said do not use a calculator, they meant leave it like this. Don't go and plug in ln of 11 to get a decimal that you're then going to combine with 6. This is what we call an exact answer, no calculator. Okay, moving on to number 15. 15, you're doing the ln of the 9th root of x. So first thing you're going to want to do is write this in power form. This is going to be the ln of x to the 1/9. Okay, and so that the only thing that you can do here is you can apply the power rule. You'll be able to take this power. When you're talking about logs, that property says that the power becomes the coefficient. So the 1/9 swings out front, and then it's just ln of x. Excuse me. Okay, problem 16. You have the log of a product with a power, base b. So if you're going to deconstruct this into single terms, a product is taken apart. Here's your product right here using plus signs. It becomes a sum. So it's log of y plus log of z to the 7th, both having the same base that the original had. Then one more property can be applied, and that is the power property for logs. The 7 comes out front, and then it's just log of z with a base of b and also a base of b here. Okay, 17. In problem 17, you have a quotient that you're going to take apart. The top of it is x minus 6, your numerator, and then your denominator is x to the 5th, base 2. Okay, so now when you deconstruct this, it's going to be log of the numerator. I'll just keep it in parentheses since there's two terms, minus, because quotients get taken apart using minus signs as a difference, and then log of x to the 5th. At that point, there's one more property that can be applied, and that would be the power property. You can take that power right down so that this becomes log of x. Don't leave powers on any of your expressions, on any of your augments. Okay, so that's a final answer there. This was the final answer for number 16. Moving to number 18. Okay, 18. Now we're going to be taking the properties to put these expressions back together. In problem number 18, it says 3 times log of x minus log of y. Both have a base of b. And since there's a minus sign in between them, that means this used to be a quotient. Now, anything that's out front is really a power that belongs to the augment. So you can swing it right back up to where it was. prior to them expanding it, and then put it together as a quotient. So this is log. You only see the word log once when you condense it. The numerator would be what's in the first term of the expression, and then this will be the denominator. Okay, and you can put a parenthesis around it or not. And then the base, little base of b. Okay, moving to number 19. In problem 19, you have, push this up, log of 9 base 6 plus log of 4 base 6. Okay, you're going to put these together as a product. Anything that's in its expanded form has a plus sign between the terms is a product when you condense it. So when you condense it, it's just the word log once. You're going to put, write the 9 and 4 as a product with that base of 6. Continue with that. So this is log of 36, and this is where you really got to apply the properties, base 6. Keep going with that. Okay, you got to be able to see that the inverse property is part of what you're seeing here, because 36 can be written as log of 6 squared, base being 6. That means that this cancels with this, takes the word log with it, and is equal to 2. Okay, that takes us up through 19. Okay, moving to number 20. In number 20, you are doing log of 334 base 21. So you could try to use the inverse property, seeing if you can make 334 out of 21s. So it's 21 raised to, let's see, log, at least common logs are natural logs. Okay, so one way you could do this if the base is not the same, so you're not going to get 334 out of 21 to any power. So if you want to rewrite this using common logs, you can go like this. Log of 334 base 10, because then you can use your calculator to do it, over log of 21 base 10. So you're basically changing the base on each of these. It was base 21. Now you've rewritten it as two different logs, but both with base 10, so that you can now put this in the calculator. So now you're going to go in your calculator and do log of 334 divided by log of 21. And you get approximately, let's see where they want us to take this to, number 20, 4 decimal places, so 1.9087. Okay, moving to 21. And by the way, this is called the change of base formula. When you can't use the inverse property, I tried going 21 to some power to see if I could get 334, and I couldn't. So then I changed both of them into base 10, since the problem said that you could use your calculator. So just be log of the argument, that'll serve as the numerator, log of this base, but now that becomes an argument. These both become the arguments, but they're now both base 10. Okay, 21. 21 is 3 to a power of 1 plus 2x is equal to 243. And when you go to do these sort of problems, since you're trying to solve for x in the exponent, you have to knock this x out of the air as the exponent. So you're going to be taking the log of each side. You can take either natural log or common log. So I'm going to be using common logs. I'm going to do the log of 3. Now, if there were e's in this problem, I would probably choose natural logs, but in this case, there's no e's because e is the base of a natural log, so I'll just use common logs. So it's log of 3 to a power of 1 plus 2x, and then you take the log of the other side as well. And once you take the log of both sides, then you can use the log property. So one of the log properties is that powers become exponents. So now you're going to swing this right down in front of the word log. It'll look like this. 1 plus 2x times log of 3, and these are base 10s, is equal to log of 243. Okay, so now you want to try and start solving for x. Try and start getting the x term by itself. First thing you're going to do is divide this log of 3 right off of the left side. So it'll be gone on the left side, and you can put that into your calculator. This is 5. The log of 3's are gone there. You're left with 1 plus 2x on the left. And then you're just going to solve for x. So minus 1 minus 1. 2x is equal to 4. Divide by 2 on both sides, and you get x equal to 2. And that's the answer for 21. Okay, problem number 22. Okay, problem 22, you have e raised to a power of x plus 3. And the problem with these is that what you're solving for is up in the exponential position. So until this chapter, you were never really dealing with that. So what knocks this out of the air is you taking a log of each side. Now in this particular problem, since it has e's in it, I'm going to use the type of log that's compatible with that, which is natural logs. So I'm going to go natural log on this side, natural log on this side. And then I'm going to try and show you the inverse property working on both sides actually. So this would be base e. This is also base e. So on this side you see that the augment and the base match. Take the word log with it. You end up with x plus 3. Over here, if you don't already see it, there's a base of e. This augment is really e to the negative 7th when you write it in power form. Anything that's occurring in the denominator can be written as that expression with a negative power, and then it's no longer a fraction. And you need to write it like that so that you'll see that this matches with this. Only when you have a base and a power will that happen, the inverse property. So these two cancel. Take the word log with it. This side is equal to negative 7, while the left side's x plus 3, and then continue to solve. Bring this 3 to the left-hand side, or to the right-hand side, sorry. You get x is equal to negative 10. Okay, that takes us to 22. A few more on this practice test. This is number 23. And 23, you have e to the x plus 8. And on the right-hand side, you have a 2. I'm going to take the same approach. I'm going to knock that power right out of the air by taking the log of both sides. I'm going to use natural log just because there's an e in this problem. And like all equations, whatever you do to the left, you have to do to the right. Now on this side, this is going to cancel with the base that is occurring on all natural logs. Base E, augment is E, therefore they cancel, take the ln with it. And down comes the power. Right here, now let's see if they want exact answers. It says express it in terms of natural logs. I don't think they want a decimal there, but I can show you how to get both. So if you're not going to actually press that into the calculator, that means you're going to let it hang around as is in the answer. So in other words, all you would do at this point, don't touch your calculator, just isolate for x. Just move the 8 over here. So it'll be gone, and you'll have x is equal to ln of 2 minus 8. If someone asked you to get a decimal approximation for that, you would press in ln of 2, just touch the ln key, then 2, and then subtract 8, and then you can round it to whatever place they've asked you to. This is called an exact answer, when you leave it in its exact log or ln form. Okay, number 24, getting close. And number 24, you have log. Now this already has a log in it. So this goes back to one of the earlier sections in the chapter where you're learning to go from log form to exponential form. The 3 problems that I've just done, 23, 22, and 21, notice that all 3 of those problems, none of them started with a log in the equation. You're the one that took the log out of each side. So 21, so number 21, 22, and 23 is where the power is made out of a variable and you're trying to knock it out of the air. That's when you take the log of each side, either common log or natural log. Okay, so this one is you're rewriting a log in exponential form. So you're going to push this up to the power that's over here. This, remember, this switches side. This comes over here and it becomes the power on this base that you're pushing up, and all of this comes and takes its place. Okay, 4 to the third, that's 64. 64 is equal to x minus 4, and then just move this to the other side, and you get 68 is equal to x. Okay, that's 24. 25. 25, you have log of 3x is equal to log of 5 plus log of x minus 4. Now you see that in this problem, unlike the other ones I've given you thus far, you already have log in the problem, but you have the word log appearing way too many times. You want it to appear once like this so that you can use the rewrite method that I did here, where I pushed the base up and I switched the 2 sides of the remaining items. You want that to happen here. So what we're going to do here, and that's if you can get it to happen. When you have logs on both sides, I'll talk to you about another approach that you can take, which is even easier. If you can get it down to 1 log, but when you have logs on both sides like this one does, then you're going to see, I'll show you what to do for this one. So first let's condense the right-hand side. A plus sign in between 2 logs can be combined into a single log in product form. So we're going to make a product of 5 and x minus 4. The base is 10. Base on this one's 10. And over here you have log of 3x. If you get into a situation where you have a log on both sides, you can just cancel the logs. Not in the case where there's 1 log, but when there's 2 logs like this, you can just cancel the log on each side. Because the only way this log could be equal to this log is if the augments are equal. So therefore you can disregard the logs, but only in the case where you have 1 on each side, and use just the augments. Okay, so it's this augment equal to this. That's what's going to allow you to find the values that would make this side equal to that side, and you solve it as an equation. So 5x minus 20 is equal to 3x. Get all the x's on one side. I'm going to move these over here. And it's negative 2x equal to negative 20. Divide both sides by negative 2. And you have x is equal to 10. Now with any of these solutions that you're finding, and that's for these equations that already have the word log in it, you need to check your solutions. Because in the solutions that you're proposing, the numbers that you're finding, they cannot make the argument negative, nor are they allowed to make them 0. So you got to be careful with that. No, nothing should be given for an answer that creates a 0 or a negative number here. Okay, so like for instance, this answer that we got, number 24, when you put it right in there, you end up with 64. So that's fine. Okay, you just don't want to create a negative or a 0. This answer that I'm finding, a 10, it can't make any of the logs in the original problem negative or 0. So when you put it in there, you're good. You can't plug into that one. When you put it in there, you're good. So this answer is fine. It's the true solution, because if you find an answer that does create negatives or zeros in the augment, you have to throw it out and say no solution. Okay, last two problems. This is 26 and 27. That's good. It's my last piece of paper. Last two problems. So for 26, there is log of 5 plus x minus log of x minus 4. And on the right side, there is log of 4. Okay, again, the word log appears way too many times. You need to clean up and condense as much as possible. But you see that there's logs on both sides, so you are going to be finishing this problem as I finished problem number 25. That's the approach you're going to take if you have logs on both sides. Okay, so let's see, condensing these. A minus means that it can be condensed into a quotient. This will be the numerator, the 5 plus x, and this will be the denominator. Okay, so now I have these two combined into one log, and then over here I have log of 4. Okay, and so in any situation, 25 and 26 are examples, and 27 is going to be example also, where you have a log on both sides. You can just strike the logs, because the only way for this log to be equal to this is if their augments are equal. So you might as well get rid of the logs and work just with the augments. So here's the augment of this log, and this is the augment of the other one. So you get into a situation here where this is just cross multiplying. Okay, if you want to look at this as 4 over 1, you can, but it's just denominator on one side gets multiplied by the numerator on the opposite side of the equation. So it's 4. This is going to swing up right next to it, giving you this expression on the right-hand side. Then you're going to do the same thing going the other way. It's going to be 1 times 5 plus x, 5 plus x. Now distribute. You get 4x minus 16. And over here, 5 plus x. Get all the x's on one side. I'm going to move this x to the right, leaving me with 3x while moving the negative 16 to the left, which will give me 5 plus 16, 21. Okay, then divide by 3, and then we're going to check to see if this destroys or violates any of the augments. Okay, so the 7 placed into the first augment produces a positive. You're fine there. The 7 plugged into the next augment leaves you with a positive. You're fine there. So that means this is a good solution. And you will give that for the answer. Last problem, 27. Okay, in 27, again, you have multiple log expressions. Okay, on the left side you have two different logs, but you can combine them into one. So that's pretty much the point of 25, 26, and 27. On one side you have more than one log. You're going to put it together using the properties of logs. Okay, property of that says how to put the sum of two logs together is that they used to be a product. A sum becomes a product. So you can write this side as a single log, just like that. And on the other side you have ln of 12. And then in any problem, 25, 26, and 27, where you have one log on each side, you can disregard the logs and work just with the augments. So on this side you have x times x minus 1 is equal to 12. Okay, so this is, you're going to have to factor here. This is x squared. Get another pencil. This is x squared minus x. I'm going to bring this 12 over here, at which point it would be a negative 12, because when you're solving second degree you need to zero out the equation and then factor this. Okay, this is the guess and check method. You break up the x squared into x and x, and then think of two numbers that multiply to give you this, but when you add them up you get negative 1. So that would be 3 and negative 4. 3 times negative 4 is negative 12. That's the back number. But when you add those two numbers, you get the negative 1 that you see right there in the middle. So negative 4, positive 3. Doesn't matter which one you put first or second. And then the actual solutions are the opposite of what you see inside the factors. So you can go through this step or not, where you make little equations out of each factor. This would give you x equal to positive 4. This would give you x equal to negative 3. Don't forget to check these solutions to see if either one of them or both of them need to be thrown out. Okay, so the 4. If you put a 4 right here, you are going to have a number that's fine. You just can't have a 0 or a 1. If you put a 4 in there, you'll have a 3. Perfect. So this one's good. Then the negative 3, the minute that you go and plug it into the first term of the expression, it violates that first term. Throw out that solution, and your only solution then is 4. Okay, so don't forget to check. You're only checking in problems where the problem starts off with some kind of log in it, like in 25, 26, and 27. That completes the review for Chapter 4.